Hi friends, in this video we are going to be doing chapter 5, that is complex numbers and quadratic equations. But in this particular video we will be just starting off with the concepts that are required for complex numbers. Of course, quadratic equation has been removed from the syllabus for this year. But of course we will continue with that, and then of course I'll be solving that quadratic equations also, just for those students who need more knowledge. Now, before we really jump into these complex numbers, let's study through some basics. Let's talk about some basic concepts that will be required to proceed forward with complex numbers. Now, if you watch closely, there are certain numbers actually beyond the real number system also. Okay, not every number is well defined within the real number system. There are numbers which are beyond the real number systems also. Now, what are those numbers which are actually beyond the real number systems? Let's look at one example. I'll give you one example and you can just try to answer that through this example. And then of course, definitely you'll get an idea what we are trying to solve here. Now, when you look at, okay, root over of 16. Of course, it is very much related to class 10, continuation of class 10, but how, I'll try to connect that later on. See, the square root of 16, what is the value for square root of 16? The square root of 16 is how much? That's 4. That's quite simple because we use the concept. Square root of 16 will be what? 4 into 4, so that of course is 4. No problem with that. Okay, what about square root of 81? Now that is also easy because that's like 9 into 9, so that's how much? 9. So that's not a big problem, isn't it? So you must be wondering, this do we already know, but now have a look at this. What will be the square root of minus 25? What will be the square root of minus 25? So your immediate, don't tell me that I am wrong, but I think your immediate, the first thought that came to your mind was minus 5. And who knows, some of you, if I had written minus 5, you would have just said yes and all. But think again, is it really going to be minus 5? It's alright, that's just normal, but I'm very sure that most of you have got minus 5, as I might have assumed. But how can it be minus 5? Because when you look at the concept, how do you find out? That's going to be minus, because minus will remain as minus, negative value. At the most, we can have 5 into 5. So, as per the basic rule, 5 can be taken out of the root. We will still be left with minus 1. So now what will be the value of this minus 1? Again, some of you may have just thought, okay, so root of minus 1 will be of course minus 1. Now that is not possible, isn't it? Because see, to go for this concept, we need to have minus 1 into minus 1. Now that is not possible because minus into minus is plus. So we just cannot extend that. At the most we can have minus 1 into 1. So that will again give me 5 into 1. Again into root of this minus value will always be there. Now this is something which actually cannot be solved. This simply cannot be solved with the basic rules of mathematics that we have here with us so far. That is square root of minus 1. So how am I supposed to remove this minus 1 from the square root? Is it possible? No, literally it is not possible. And so that's why, see, everything is not explained in this world. Everything is not explained. Everything doesn't have an answer. Okay, there are certain questions which are still left unanswered. These are some of those questions which are still left unanswered. Okay, because see, it's not that every time I will be coming across square root of a positive number only. These situations will also come. Now, what are we going to do with this? So that's why if you remember in class 10 when we were doing quadratic equations, about the discriminant d. So if you remember, of course we'll go back to that, but later on. If you remember the value of d, so about the nature of roots, if d equal to 0, then we used to say that they are real and equal roots. If d was greater than 0, then we say that the roots are real. But if d is less than 0, we say that the roots are unreal. So now this is that portion, because from quadratic formula, as per quadratic formula, the value was minus b root over of d equal by 2a. Now, if d is less than 0, that means this is less than 0. That means this is going to be a negative value. So, of course, in class 10, we don't solve this part. We solve only these two conditions. and this one we just say that okay, the roots do not exist. But now we are going to study further how and why does this case arise, maybe later on. Now we will just discuss about of this root over of minus 1. So how am I going to solve this root over of minus 1? As I just said, it is not possible. This remains here itself only. We cannot go beyond, and that's why the Greek, they gave a special name to this particular problem. And the Greeks, what they have done is they have called this problem, they have named this particular problem as iota, and it is written in short as I, which actually represents an imaginary number. So that means square root of minus 1, which is really literally not possible to solve with the basic laws of mathematics that we have with us, remains as iota, that is I, which is, in other words, what? An imaginary number. So that's why as I was telling in the beginning of the video, that there are numbers which are actually beyond the real number system also. Not every number can be explained within the real number system. There are certain numbers which cannot be explained, which are not real. In short, there are numbers which are actually not real, which do not exist. And what we call that particular numbers? We call them imaginary numbers, because from here we cannot proceed further. So just for the sake of calculation, what we do, what the Greeks they have given us is that they have just named this as iota, which will be considered as now imaginary number system. Now, before we really proceed further, that I will continue in the next video only. Today, let us just learn something more about this the concepts that leads to complex numbers. Today we will just learn about this iota. Okay, so now the value of I, that means the value of I is how much? Root over of minus 1. So some basic things, I hope you are writing it down. What will be the value of I square? These are some basic things which we will need. So I square will be what? Root over of, because the value of I is minus 1, root over of minus 1 square, that will be what? Minus 1. Take a note of it, okay? What will be I cube? I cube will be what? I square into I. So that's this. What is the value of I square? It is minus 1. And I, of course, remains I. So I cube can also be written as minus of I. What about I power 4? I power 4 we can write it as I square into I square. So that will be minus 1 into minus 1. So that will be what? I power 4 will be plus 1. Okay, so let us try to remember these values. And based on this iota only today, let us just try to solve some questions which will definitely prove to be very useful and beneficial for us as we proceed further with the chapter complex numbers. Now let's try to solve some problems. I hope you have written it down. So let's just try to solve some complementary problems like question number maybe 1. So let's try to solve, okay, what will be the value of I power 7? Let's try to solve this I power 7. So, see, I power 7 I can write as 4 plus 3. You can do it in other different ways also. No, 7, of course, we can expand as 2 plus 2 plus 2 plus 1 also. No problem with that. But I prefer using I power 4 because I power 4, as we have just done, it is actually 1. So that's much easier and more comfortable for us. So now this I power 4 can be written as I power 4 into I cube, isn't it? So now what is the value of I power 4? 1. What was the value of I cube? Minus I. So this value of course will remain as minus I. Got that? Okay, another problem. Square root of minus 1 whole power 90. So what will be the value of square root of minus 1 whole power 90? So minus 1, root over minus 1, we can again write it as I. So that will be I power 90. Now I power, in terms of multiples of 4, how can we represent 90? Is it possible? Definitely yes. We can always divide by 4. 4 2s are 8. 1 left 10. 4 2s are 8. So 2 is a remainder. So that means I can write 4 into 22 plus 2. Isn't it? Because 4 into 22, right? The division algorithm, 4 into 22 plus divisor into quotient plus remainder is equal to what? Dividend. Isn't it? So that can be written as I power 4 22 into I square, right? Laws of indices, not a big issue there. So 1 power 22 into I square is what? Minus 1. So that of course will be minus 1. Alright, so these are certain calculations which we will be needing. Another question, that I power n plus I power n plus 1 plus I power n plus 2. These are sometimes important for your competitive examinations also. Okay, so please give importance to this particular video also. So this one I can write I power n plus I power n into I power 1 plus I power n into I power 2 plus I power n into I power 3. I believe all of you know the basic laws of indices, exponents and all. So now from each of these 4 terms, I will take out I power n common. So that will be 1 plus I square plus I cube. So that is I power n, 1 plus I. I square, what was the value of I square? It was minus 1. And I cube, what was the value of I cube? If you have written down the notes, you will see there that was minus I. So I 1, 1. So this is simply nothing but 0. Alright? Written? Okay, I'm rubbing it off. Another question. So this will be good practice for all of you. Another question. Show that minus root over of minus 1. Okay, show that minus root over of minus 1 or 4n plus 3 is nothing but I. So let's try to solve. Minus root over of minus 1 whole power 4n plus 3. That's simply minus, I know, because root over of minus 1 is I, isn't it? 4n plus 3. So that I'll write minus I 4 or n into I cube. So that can be written as I power 4 whole power n into I cube, isn't it? That's not a big problem there. So I power 4 is 1. 1 power n into I cube is how much? Minus I. So that will be minus equal to minus 1 power n. This is 1, okay? Because I power 4 is 1. So 1 power n, and 1 power anything is always 1. 1 into I cube is minus I. So that's going to be minus I. So that's minus of minus I. So that will be minus into minus plus I. Simple as that. Alright. So that's our proof. Okay. So one last question. Okay. One last question. Let's quickly do one last question. That is number 5. So let that question be I power 104 plus I power 109 plus I power 114 plus I power 119. So let's try to solve this. Let's try to get multiples of 4. So this one, how can we write? 104. We can quickly divide 104 divided by 4. 4 ones are 8, 2, 4, 4, 6 are 24. So 4 into 26 plus I power, this one, 4 into 27 plus 1. Isn't it? Let's see. 109, 4, 4 2s are 8, 9, 10, 29, 4 7s are 28, so 1 remainder. Alright, not a big problem there. What about 114? I power 4 into 114, that is like, okay, quickly, 114, 4, 4 2s are 8, 9, 10, 11, 3, 34, 4 8s are 32, so 2 is the remainder. 4 into 28 plus 2 plus I power 119, 119, 4, 4 2s are 8, 39, 4 9s are 36, 3 left. So 4 into 29 plus 3. Okay? Alright? Okay, so that is like I power 4 into 26 plus I power 4 into 27 into I power 1 plus I power 4 into 28 into I square plus I power 4 into 29 into I cube. So I power 4 is 1, 1 power 26 plus 1 power 27. I power 4 is 1, isn't it? 27 into I plus 1 whole power 28. I square, what was the value? Minus I square, the value was minus 1. Plus, this is again 1 power 29. I cube was how much? Minus I. So this is 1. This is 1 power 27 is 1. 1 into I will be I. This is 1 power 28, that is 1. 1 into minus 1, that will be minus 1. This is minus I. So I, 1, 1. That is how much? 0. Alright. So this was some of the basic problems based on this iota. You will come face to face with this kind of problems on iota every now and then when we begin with when we start solving and understanding complex numbers. So this was just a basic introductory class for this chapter 5, complex numbers. So in the next video only we will really study what are complex numbers, but for that we need to have this at our background. So that's why I decided to just make this one video purely based on this imaginary number system. So again, turning back, what was I? It was iota, a Greek letter which also means imaginary numbers, right? Imaginary numbers, and its numerical value is what? Root over of minus 1. So this will be important for you to proceed further with complex numbers. So in the next video, we will talk about complex numbers and the basic details that is required with complex numbers. So alright then, till then, see you in the next video. Stay safe, do like and subscribe, and please do share. Alright, thank you.